Welcome to this explainer. Today, we're unpacking a really fascinating topic, architects of the digital mind and understanding computer logic. Look, if you're someone who loves to know exactly how things work under the hood, you are absolutely in the right place. We interact with computers, smartphones, and AI every single day, right? And honestly, they seem incredibly smart, almost magical sometimes. But to truly understand them, we have to look at the foundational building blocks of the digital mind. And more importantly, we need to understand how those blocks differ fundamentally from our own human intuition. Because our brains and computer brains, they operate in entirely different universes. And understanding that architectural gap, that's the real key to mastering the technology all around us.
So let me ask you, can you bake a cake without a recipe? If you're human in a kitchen, you might just be able to pull it off. You rely on your senses, your past experiences, maybe a little bit of guesswork. You taste the batter, realize it needs a pinch more sugar, or maybe add a splash of milk because it just feels a little too dry. We guess, we adapt, and we intuitively figure things out. But a computer? No way. A computer absolutely could not do this. If a machine doesn't have the exact measurements and the precise order of operations, well, there is no cake. There's literally just a system crash.
Okay, let's jump into Section 1, Ultimate Rule Followers. Let's really dive into the reality of how these machines operate. Simply put, computers cannot guess, imagine, or feel. As humans, we rely so heavily on those three traits that it's actually kind of difficult for us to imagine problem solving without them. But computers, they are the ultimate rule followers. They require precise, explicit instructions for absolutely everything they do. When you type in a simple command, the computer isn't anticipating what you want using its imagination. It is blindly, rapidly, and perfectly following a strict set of rules laid out in its programming. It doesn't infer a single thing, it just executes.
Which brings us to Section 2, the need for precision.
We really need to understand exactly how specific a computer's instructions must be just to avoid a complete digital standstill. To grasp this, let's think about the robot game. Imagine you're giving instructions to a person who's pretending to be a robot. If you just say, "Walk to the door," a human brain instantly calculates the distance, notices the coffee table in the way, and naturally navigates right around it. But a machine hearing "walk to the door," it has no idea what walk means, what a door is, or even how to move its joints to get there. Instead, you have to break the whole thing down to its most granular level. Step 1, take one step forward. Step 2, take another step forward. And if you don't explicitly tell that robot to stop, well, it's going to walk straight into the wall. It perfectly highlights why vague commands fail, but precise step-by-step commands succeed.
Moving right along to Section 3, Facts, Not Feelings.
This deep need for precision brings us to a huge emotional distinction between humans and machines. There's this wonderful anecdote from our source material about a little girl who told her brand new toy robot, "Make me laugh." She waited for a joke or maybe a funny little dance, but the robot simply replied, "Command not understood." It's a funny moment for sure, but it perfectly encapsulates computer logic. The machine literally didn't know how to execute the command, "make laugh." And more importantly, it doesn't know what a laugh even feels like. Computers just process programming. They don't get a little thrill of happiness when they successfully run a program, and they certainly don't feel sad or embarrassed when they glitch and produce an error. They just process facts, completely devoid of all emotion.
And this brilliantly illustrates the stark philosophical contrast we're talking about today. The human mind is defined by feelings, creativity, and intuition. The digital mind, conversely, is governed exclusively by facts, rules, and exact instructions. When we use technology, we are essentially trying to bridge the gap between these two totally distinct universes. We're using our creative, intuitive human minds to write the factual, exact instructions that the digital mind needs to even function.
Let's look at Section 4. Humans are in charge. Now, realizing that our devices are entirely unfeeling might sound a little bit cold at first, but it's actually an incredibly empowering concept. Our human feelings and creativity are special, and precisely because computers lack them, we get to design the rules. The absence of emotion and intuition in machines keeps us, the humans, firmly in the driver's seat. We're the architects here. A computer can process 1,000,000 calculations in a single second, but it absolutely cannot decide which calculation is morally right, creatively beautiful, or genuinely helpful. It needs us to provide the purpose. Understanding computer logic is a great reminder that we are the ones in charge of guiding technology and giving it the right boundaries. Let's see this in action in Section 5, Real-World Computer Logic. Let's take all of this out of the realm of theory for a second and see how these exact, unfeeling rules actively solve problems in our everyday lives. Think about a smart traffic light in a busy city. The old way of managing an intersection was just using a simple blind timer, right? The light changed every minute regardless of whether there were 50 cars waiting or absolutely zero. But a smart traffic light uses computer logic. It's programmed to actually see how many cars are waiting at each street and adapt to the traffic volume smoothly. It doesn't rely on some rigid, ignorant timer. It relies on a dynamic, logical condition.
The core rule the system is following here is super simple. More cars equals a longer green light. The traffic light doesn't feel bad for the drivers who are running late for work. It doesn't have a personal preference for which lane gets to go first. It simply processes the data it receives against this predefined rule. By following this exact instruction without any bias or emotion, it successfully keeps traffic flowing smoothly for everyone. It's just a perfect, everyday example of how rigid computer logic serves our human needs.
Wrapping things up, let's head into Section 6. Next up, algorithms.
So, we know that machines need precise rules to function. But how do we actually input these vital rules into the computers? Well, the answer is algorithms. Algorithms are simply the step-by-step recipes for computers. Think all the way back to our initial baking metaphor. Since the computer can't guess how to bake the cake, the algorithm is the exact unchangeable recipe we hand over to it. It's the sequence of precise instructions that translates our human intent into digital action. Literally, every app you use, every video game you play, and every smart device you own is driven by these step-by-step recipes written by human architects.
Which leaves us with one final, really vital question to ponder. What rules would you write for the digital minds of tomorrow? You now know that computers aren't thinking for themselves. They are literally just waiting for our instructions. They're waiting for your creativity, your intuition, and your empathy to be translated into their language of logic. So as you navigate the digital world today, just remember that behind every single screen is a literal rule follower, simply waiting for a human architect to give it a brilliant recipe. Keep exploring, keep learning, and start thinking about the instructions you want to build for the future.